Welcome to day 2 of remote learning, Math 1B. I have 3 goals to talk about with today's lesson. I'm likely going to have to split this up into 2 different videos because I have 8 examples I want to go through. That's okay, just be patient and watch as we go along. So, the first thing is just to be able to simplify expressions involving powers and division. So this one is a pretty good just representation of basic numbers. We're going to simplify this. 0 exponents and negative exponents are the ones that are probably going to require us to talk a little bit more deeply about that. So, example 7 on the notes that I printed off on Google Classroom. We have, first of all, a coefficient 24 divided by 9. Now, when you think about what 24 divided by 9 is, we can represent that as a mixed number, a decimal, or reduced fraction. So 24 divided by 9, we can divide the top and bottom by 3 to get 8/3, which is the same as 2 2/3, or 2.6 repeating. Now, just to keep things simple, we're going to end up having a fraction with powers that are going to nest on the top of the fraction and some that are going to be on the bottom. So it makes sense to establish this fraction instead of a decimal and a mixed number. So from here on out, just make sure you guys are representing the coefficients as simplified fractions. So part 1, we've got 8/3. That's just the coefficient part of it. Now, in order to simplify a⁴ we can look at it as a⁷ is actually a times a times a times a times a times a times a. 1, 2, 3, 4, 5, 6, 7 a's multiplied in succession. And you can divide that by a times a times a times a. 4 a's multiplied in succession. Now, when you have anything divided by itself, you should get 1. That's just basic properties of division. So a divided by a simplifies to 1/1. So this is 1/1, and this is 1/1, and this is 1/1. So that should leave you with 1 times 1 times 1 times 1, which is 1. A would be a⁵ power divided by 1 times 1 times 1 times 1. So really all we have is an a³ on the top part of this final answer, because 8 times 1 is just 8, and 3 times 1 is just 3. Now, I don't know if you guys can see this, but 7 minus 4 gives you 3. There's the simplifying rule. All we'd have to do is subtract these exponents, and we're good to go. Now, I just said that anything divided by itself is 1, so b⁵ over b⁵ is just going to cancel itself out, period. Now, this is interesting. I'm going to hold on to this to talk about 0 exponents in a minute, because if we use that idea that b⁵ over b⁵ can be simplified by just subtracting, we're left with this 0 exponent. I'm going to leave that for the next example, but it should be intuitive that b⁵ divided by b⁵ is just 5 b's on top, canceling with 5 b's on the bottom. 1, 2, 3, 4, 5. And you're just left with basically 1/1, which equals 1. So anything times 1 is itself, we can just cancel out those b⁵s altogether. Now this is interesting. You've got c³. I ran out of room here. That's okay. c³ divided by c⁷, if we do the expansion that I showed here and here, it shows us, so c, 4, 5, 6, 7, that these will still cancel as 1/1. 1/1, 1/1. which means that you should have a 1 on top and a c on the bottom. So c to the 4 on the bottom. Now this is our final answer. And the interesting thing about this is it exposes what a zero exponent is, and it actually also exposes what a negative exponent is. Because c to the 3 over c to the 7, if we use that shortcut property of just 7 minus 4 here and 5 minus 5, 0 here, 3 minus 7 is going to be c to the negative 4. So right now, we've got this idea of negative exponents staring at us, and we've got this idea of what a zero exponent is here too. So let's talk about example 8. In example 8, we've got negative 12, a to the 0, c to the negative 1, all over 20b to the third power. Now from this example down here, I showed that b to the 5th divided by b to the 5th can be represented as b to the 0 power. But I also showed that b to the 5th divided by b to the 5th can also be represented as 1. So this is kind of like a little mini proof that shows b to the 0 equals 1. In fact, any base taken to a 0 power ends up being 1. It's just one of these strange things that happens when you do calculation properties that doesn't seem to make sense, but through proof you can show that, hey, anything to the 0 power actually just ends up being 1. So whenever you see a to the 0 power, or anything to the 0 power, you can just say that a to the 0 can be replaced with 1. Not a to the 1, just 1. And we're still talking multiplication here, which means negative 12 times 1 is just negative 12. So technically, those 0 exponents kind of can just disappear at will, because anything times 1 is itself, and yeah, you can get rid of them very easily. So 0 exponents, they're not that big of a deal. Negative exponents, though, tend to give people some problems. So if we look at this over here, c to the negative 4 is equal to 1 over c to the 4. If you think about what c to the negative 4 is, it's sort of like a whole quantity by itself, but you can't multiply something by itself a negative number of times. So I can look at c to the negative 4 as like, if it's just a number, I can put it over 1 if I'm trying to compare it to the fraction on the other side of the equation. Now, if you think about what happened, all we did was we swapped the c to the negative 4 from the top and we put it on the bottom. By placing it on the bottom, it creates a positive exponent for this one. So that's kind of like the quick trick, is if you have a negative exponent, like this one right here, all it requires is that if you move it to the opposite part of the fraction, it creates a positive exponent. So if c to the negative 1 is equal to 1 over c to the positive 1 power, that just means I can rewrite it in the bottom part of the fraction. So now I'm left with b cubed. B cubed was always on the bottom. I'll try to keep my colors in line here. And then now c to the 1 power is on the bottom. I can just call it c though, because, hey, that's c to the first power right there. Now, this is where students oftentimes will get confused, especially with a negative coefficient. They think, all right, you move the c to the negative 1 to the bottom, move that negative 12 to the bottom and make it positive. We're actually not going to do that, and here's why. The exponent for the number negative 12 is negative 12 to the first power, just like 20 is to the first power. They're positive exponents. Positive exponents do not move to different parts of the fraction to become positive exponents. So you technically just have negative 12 20ths, which you just reduce as a fraction. I mean, if you think about it, the biggest number that divides 12 and 20 is 4. So I just divide the top by 4, which gives me negative 3. Divide the bottom by 4, which gives me 5. And there we go. All right, so that gives you the basics of zero exponents and negative exponents. I want to do a couple more examples on just these before we talk about some more complicated ones. All right, so number 9 over here. I'll rewrite it so it's larger so everybody can see what we're talking about here. And by the way, guys, I am throwing a lot of abstract stuff at you. There are some practical applications, especially when you talk about astronomically tiny numbers, when you talk about negative exponents. I'm just throwing out some brain candy here for you. All right, so the rule seems to be that all we got to do is simplify the coefficients if they have positive exponents, which in this case they do. If I see no number here, so it's just to the first power here, to the first power here, just like this u is to the first power down there, I'm just simplifying that. So negative 3 divided by 12 is the same as saying you've got negative 1/4. So I got negative 1/4. Let's see here. Yeah. Now, it should be moving day for anybody who's got a negative exponent. So that t to the negative 4, I'm moving that to the opposite part of the fraction. So if it's t to the negative 4 on top, it's going to be t to the positive 4 on the bottom. If it's t to the negative 7 on the bottom, it will become t to the positive 7 on top. If it's x to the negative 8 on the bottom, it's going to become x to the positive 8 on top. Now, I could go into greater detail about this, but I kind of did that back in August, and since we're just reviewing this stuff now, I'm going to lay off that heavy explanation. Anybody who is just a positive exponent remains where it is, so the u to the 8 is going to chill out on top. The u to the first is going to stay on the bottom, and the x to the 4, well, it remains on top. Okay. At this point now, you use your knowledge of how to multiply powers for the ones that are on the same side of the fraction. So if we've got 2 that are in the top that have the same bases, so I got x to the 4 and x to the 8 on top, those will multiply together, which if you remember yesterday's video, you add the exponents there. So I'm going to have x to the 12 on top. Let's see here. I'm going to have opposites subtract. That's another way to maybe think about it. You know, like opposites attract, opposites subtract. You can kind of remember it that way. Opposite parts of the fraction will subtract. So you got u to the 7. And then, again, they're in opposite parts of the fraction. Subtract those. 7 minus 4 is a positive 3. And then the negative 1/4 remains. And that's your answer. I'm going to stop the video there and then talk about how to do 10 through 14 with, as you can see, some slightly more complicated things like what happens when you have a whole quantity to a negative exponent.